yeah, next up we got Sebastian. Sebastian is the CEO of Scalar. Let's see here. Wait. Ohad, are you still sharing? Can you stop sharing? Does everyone see my screen?
Wait.
I see a big scalar.
All right, awesome. All right, so yeah. Next up, we got Sebastian. Sebastian's the CEO of Scalar. I've known Sebastian for many years now.
Yeah.
Back when he founded Scalar in the early days of AWS. Some of you might remember a company called RightScale. They were in that category, a competitor to them. They just launched their newest platform, built from the ground up for Terraform automation and collaboration, maybe other things. He's going to highlight some of the things that really make them stand out. So, Sebastian, you want to take it from here?
Yeah, you bet. First of all, Jake, Ohad, great job. You guys did a great job presenting. Built some really cool technology. So super exciting to see this the whole market take off. And really what this is all about is just making sure people don't roll their own solutions. Just wanted to throw that out there. You can first of all, I'm Sebastian. I'm the CEO and founder of the co-founder of the company. Joining me is Ryan. He's our director for solutions engineering, and if you want to contact us, you can see our email right there. All right, so a little bit about why we built Scalar. We built Scalar because we wanted to make it easier to collaborate in the company around a Terraform centric approach to infrastructure. We didn't want to take a pipeline approach like some of the good folks here, because honestly, who wants to who wants to maintain multiple CI/CDs? And what it raises all, like, when you want to do that, it raises all sorts of problems on, like, what happens if you have some dev teams that want to use GitHub Actions or that want to use GitLab's workflow tools or any of those things. So we didn't want to put folks in a bad cop position to have to prosecute teammates that to get them to stop using their CI/CD, etc. And it really didn't seem right to us to have to have a pipeline for your application code, to have a different pipeline for your application code. And it just like in our experience, it just makes it harder to get your application devs to own their own infrastructure code if you separate those. In addition to that, we wanted to make it easier for everyone else in an organization to use Terraform. So think the folks that are not developers, folks that are developers but don't care to learn how to use Terraform. Wanted to make it easier for those folks to use Terraform and to deploy infra. And also do that without having that one guy that knows Terraform that everyone depends on to deploy or edit stuff, and that becomes a bottleneck in the organization. In addition to that, we also recognize that using the CLI is great. We want to maintain that as part of the workflow. We recognize that in some organizations and some teams, it's an entrenched behavior, so it's kind of something you can't really part with. And just using the CLI keeps you agile when debugging, iterating on your code. But we did want to have access controls and policy while using the CLI and not creating a separate path for that. So like that's what led us to create a remote operations backend. And then, like, in addition to that, like a couple last points, we wanted there to be an open source foundation to policy as code. So we took the OPA path that just was a natural choice for us. And then one of the most important things is we wanted the solution to be affordable and stay affordable even as you grow. So we have got super transparent pricing, all that. You can just go online to check it out. So there wasn't anything that fit all those criteria on the market, so we rolled up our sleeves, got to work. And I'd like to hand things over now to Ryan, who's going to share some of the stuff that we built.
Oh, unmute. Okay, thanks, Sebastian. So what I want to talk to you quickly about today and have a brief demo is going to talk about some of the most common use cases that we see from our customers. So the first use case that we normally see when customers come to us, they say they've already got an existing CI/CD process in place. They're already using Terraform open source, but they need to scale it up a bit. So what we do at Scalar, we allow you to continue to use that workflow because Scalar works with Terraform native API and CLI. So using that, we easily allow for migration of state in, giving you that low barrier of entry into Scalar. So what you're going to see here is that, I just already ran a plan, and I already ran an apply And we can see the standard native Terraform output that you normally expect to see with the added advantages of Scalar, like Sebastian mentioned. So in here, we have the cost estimation. In this case, it was provisioning VPC, so there was no cost. We have our open policy agent to make sure we're abiding by compliance standards. We also have the state locking going on in the background. I didn't provide any provider credentials to this because that's all stored in Scalar, or I can integrate with various things like Vault or any other cloud credentials systems. And then lastly, of course, RBAC. So I can only do exactly what the administrators are allowing me to. So one of the things, though, is we understand that this is a stepping stone, and most companies want to get to that GitOps approach. For the GitOps approach, we've also enabled the ability to integrate with your VCS repositories. So here you'll see one of our workspace screens where I've integrated with a repository. We've set up that GitOps approach, and I'm able to do the dry runs, the testing, everything that I need to do prior to maybe merging something in master, and really implementing that automated testing through VCS. The key in this use case, the key in this use case is really giving our customers options, whether they want to use the CLI, the VCS approach, or the API. The next use case that I want to talk about is our module registry and our template registry. And this really focuses around standardization, centralization, avoiding potentially breaking changes. So Scalar, we've created a module registry. And as you can see here, the module registry has a couple different colors here, and that represents what we call scopes. You can create modules at what we call a Scalar scope, count scope, or environment scope, following our hierarchical inheritance model. So for example, here, if I look at this one module registry, as an end user, I've automatically inherited this. I can grab the source code for the VPC, but I can't remove it. I can't change it. I can't pin versions. I'm getting exactly what that administrator wants me to have. We also have then a template registry. The template registry really you can think of as something that is for two types of users. Maybe a potentially somebody that has a skills gap in terms of Terraform and is not up to speed on it, but you're standardized on Terraform as your way to provision, or somebody that really knows Terraform well already and wants an easy way to onboard a workspace or their configuration file. So we're pulling in from the VCS providers Terraform configuration files and making it easy for your end users to be able to provision directly from this service catalog look and feel. And the end result is then you're getting this is coming through the Scalar pipeline, and we're checking costs, we're checking the policies, doing everything you normally expect out of this. Again, this really is both of these features are following our hierarchical inheritance. So the idea behind that is, as an administrator, you might want to enforce module registry across all of your various environments. And environments in Scalar, every application team can have an environment, and you want to make sure that they're following standards, but you don't want that additional overhead of having to go into every single one of these environments and create that registry. So that's where I now jump up to what we call the account level, where I can create those modules, where I can create the template registry and automatically have those pushed down to all of my environments. The third use case is really somebody's coming to us. They don't have many issues with Terraform. Everything's pretty much working at scale, but they want to get to the point where they want to use policy as code. They want to be more compliant or potentially improve an inefficient PR process. So in this case, as Sebastian mentioned, we've settled on, or we've standardized on open policy agent, being that it's open source, can be used across the ecosystem, really grew up in the Kubernetes community, as most of you know. We wanted to go with OPA. And one of the really cool things that we did with OPAs is not only do you see as an administrator or as an environment admin, what is going on in your current environment, but what we also have implemented is the ability to preview what's going to happen with policies that are currently have a PR in them. So I want to know, if I implement this policy tomorrow, what is going to happen to all those workspaces as soon as I implement it? Am I going to break everything? What's that blast radius? So these group policy checks that we have here basically is looking at all the workspaces, all the environments across my account. And if I was to merge this to master today, it's going to tell me exactly what's going to happen. This gives me the ability to go out, contact the workspace owners, let them know that something might not be compliant anymore, or it gives me the opportunity as the administrator to ensure that my policy isn't going to blow up production. So some of those are the three use cases that we really wanted to focus on.
One
Again,
minute.
Just to recap, so you might already have your CI/CD process in place where you're using that native Terraform open source command line and want to just scale that. You might want to standardize and centralize, avoid breaking changes using our module registry, template registry, and then lastly, bring compliance to your workflow using our open policy agent integration. Thank you everybody for joining, and we look forward to hearing from you.
All right, Ryan, that was great. Thank you, Sebastian and Ryan, for presenting how you guys are
Yeah,
solving that
thank you.
for enterprises.